Modern multi-storey parking is inadequate in many areas. When trying to find a space in a multi-storey car park that is filled to capacity, it can be a stressful experience on the customer. This problem is only aggravated by other drivers parking inconsiderately and blocking multiple spaces. This makes the process of finding a parking space take even longer.
Smart Car Park seeks to address these issues by providing a more streamlined, user-friendly car park services. This is achieved by directing the customer to a specific parking space upon entering the park. The space allocated is designated on a hierarchical level so that the customer will be as close to the destination as possible. While positioning their vehicle in the space, a bad parking system is in operation, ensuring that the user parks correctly and does not obstruct the surrounding spaces. Our product will be a prototype model of a car park with the user being able to choose between a space and a disabled space.
Before the artifact can be created, planning must be done. We have used Prince2 methodology to guide the team through the early planning. Also, we have used Prince2 to lay the foundation for the artifact creation. Some electric simulation to design and test the initial ideas for our car park system. After we get satisfied with our initial planning, final design for the car park system has been drawn up in PCB Wizard. This could be imported to the PCB printer to begin the assembly of the artifact.
Despite being the longest part of the project, the implementation of the design was the most enjoyable part of the project, thanks to the solid teamwork and a good preparation. As a group of engineering students, the tangible process of creating the artifact appealed to our thirst to apply our skills in a practical environment.
The core of our product is a series of printed circuit boards. A prototype board was made to ensure that at least one space would work before we made all of the others. When the test on the first circuit was successful, it was time to make the rest of the boards.
The team was organized into a single line with each member having a critical role in the development process. After each PCB was ready for attachment to the main framework, it was tested to ensure all the LED and the LDRs were correctly working. Any errors later could be attributed to the programming.
The wiring for the project was trimmed and treated with shrink wrap. Loose parts were attached to the wooden frame with glue, and the Arduino board was protected with a plastic case. These measures gave our finished artifact a professional finish.
Now we have done the hardware, software and the documentation, and now we are ready to close the project with our objectives and goals met.